Algebra 2A. This is yellow class. This is Tuesday, April the 25th. Let's go to page, let's flip to page 58. Let's see if I get to page 58. Essentially, there are three blocks we're kind of going to do. Three blocks are enough. If they're not, you can see me, and you can, what you can see me. Get a little magic. Let's go. Somebody. See, 58, 58, 58. 58 is a long problem. There are a bazillion places to make a mistake. Now, the other thing with 58, though, is 58 is actually three small problems put together. The third one is super easy because there's nothing to do. This is just an expression by himself. The guys in the middle, they're being multiplied. 3x plus 4 times 2x minus 1. To make him hard, they put that minus sign in front to mess up some people. I apologize on behalf of all the people in the world of math who figured they'd throw that negative sign in. Then in the beginning, these two aren't that bad, except they put the x squared, which will change things. So, if I had a chance to choose which one I would do first, the middle is the most common one. It's the one you've seen before. Then maybe I'll do this one and that one. So what does he want them to do? Let's start off by putting some dividing lines. This problem in front is one complete problem. The guy in the middle, he's a complete problem. And then his friend down there at the end, nothing has to happen with him. Just take the parentheses out of him, and he's a winner. There are two versions of this that some teachers do. I'm partial. I tend to do the rainbow version where I take the 3x and I multiply 3x times 2x. Then I multiply 3x times the 1. Again, this is the meat and the hard part for today. So if you're like, oh, yeah, I'll do those, then today is like a free unit, or a free standard passing for you. Then you take the 4, multiply him times the 2x, and multiply him times the 1. We are going to be distributing. Just all this cool stuff, so this takes back to just algebra 1 or whatnot. Some people do the box version. I'm going to put the box up for a second. Let's see who's seen this before. How do the teachers do that thing? They kind of put this. I'm not necessarily a box guy. I'm a rainbow guy because they give you the problem and the rainbow's there. They'll put the 3x and the 4 here. Then they'll put the 2x and the minus 1 here. Raise your hand if you've seen the box method of this. If you've seen the regular version, raise your hand. I assume the box people have seen the regular version as well. Here's what I'll do. I'm going to do the regular version in the middle. I'm thinking about doing the box from the beginning just so they can see both versions, see if they like one version better than the other. And then we'll combine them all, and that'll be the end. Hope you don't confuse. Here we go. This negative sign, just for the, as a rule, once we get the 4 terms, the 4 answers we're going to get here, we're going to change all their signs with that minus sign in front. This is the piece that messes up most students. As a matter of fact, we have even circle or erase. Circle that minus sign because he's going to do something at the very end. He's not connected to the 3x right now, just for those who may be thinking it. Here we go. Let's see if I can get some help to build this thing. Once you give an answer, you can don't answer again until we get more people. Once people completely silent, then you can jump back in. So I'm going to say what 3x times 2x is, please. And there's an extra little piece. Yeah. Letter times letter, you have to indicate how many letters you would multiply times each other by increasing the exponent. 1 plus 1. Technically, they're invisible ones on those x's. That's why we multiply this x squared times this x over here. People at home can't see it. When we multiply this x squared times this x over here, it'll wind up being x to the 3rd power. Because there's a little 2 here, and there's a hidden 1 that I guess could write. I could write it on that x, so some students would it's getting a 3 from us, either 2 and 0. How is 2 plus 0, 3? No, it's 2 plus 1. We haven't done anything with him yet. There we go. The other part that I'm doing is the red arrows will produce the red numbers, and then of course the blues are going to produce the blues as well. Just out of curiosity, for those, and I can pause here for those. Thank you. 3x times 2x. Whoever answered that, you're out of the pool. Someone else, 3x times a negative 1, please. You're out of the pool. All right, we're on to the blues. Oh, foil. Let me write down foil somewhere. Foil, where do I write foil? I was in high school, and they would say, yeah, we do the foil method. Now, I did the stuff to do it, but for a long time, I didn't know what it was. So now I make a point to tell students, FOIL stands for first, outer, inner, and last. First, outer, inner, last. Hey, what does that even talk about? So here it comes. First means I'm going to multiply the first guys in the parentheses. 3x, he comes first. 2x, he comes first. Multiply those first. I'm going to do second, the outer, that 3x, and the one that kind of on the outside, if you look at it that way, they're the outer. Inner, 4, and the 2, I'm going to multiply those third. They're on the inside of the whole thing. And last, the last two guys in the parentheses represent the last piece. FOIL. First, outer, inner, last. They're all trying to make something memorable in a subject that's not that memorable. Here it comes. Let's see. 4 times 2x. Someone please give it to me. 8x, I appreciate that. And then the last one, 4 times the negative 1, something different. 4n. This is the big deal. This is the big deal. That's it. I don't know at what point they start teaching this and why they're doing it, but some people have trouble with this. So to make it a little bit harder, they put that minus sign in there, so there's some kid like, oh, I did it. Bring down the minus sign, it's a negative 6, everybody else stays the same. No, you're a loser. I mean, I think you can say that in high school. No, you're mistaken. How about that? That's better. So here's the deal. Let's bring it down, but this time, what can I do to bring that thing down? I need to bring down a whole parenthesis around this whole thing. Let's see what happens if I do that. Should have made it green. Let's see what happens to that. They're trying to figure out, like, where do you get parentheses again? I thought we just got rid of the parentheses. Let me do brackets. This is the part where I get to confuse some people. So I'll do brackets. Brackets works just like parentheses. They enclose stuff. This minus sign is going to hit everybody inside. In math, the minus sign out front says, what is the opposite of? That's what a minus sign represents. What is the opposite of? Everybody inside. What's the opposite of a positive 6? It's a negative 6x. Most students get that part right because it's connected. Someone out loud, please tell me what is the opposite of a negative 3x? Thank you. Someone different. What is the opposite of a positive 8x? Thank you. Someone different. What is the opposite of a negative 4? And this takes a moment for someone who hates adding and subtracting positive and negative numbers. We know I'm writing this problem, you don't have to write this one, but just so you can feel why it does it. If I gave the problem 5 minus a negative 4. Now there's some people who this problem, they see it, they're like, I don't know. Some students get it. Double negative go to double positive, the teacher says. You just click, you know, you do all kinds of little tricks, but the reason it actually works is this. This question says, 5 and the opposite of negative 4. Well, 5 and the opposite of negative 4 just means the opposite of negative 4 is this plus 4. And now you have 5 and the plus 4. In other words, this thing here asks, what is the opposite of a negative 4? Oh, it's positive. And for those who've always seen this just change it to positive, you wonder, like, why does it just switch? So I can get, like, why does it switch? And then you put a negative sign out front, and then, like, they just switch everybody. Like, they're going to switch everyone. No. Just the guys in the middle. In any case, that's the reason it switches. And now you have an I, which means, for some of you, like, huh? I don't get it. At least you heard it once there. All right. So they have the middle section done. We're going to do the same thing to the beginning without the minus sign. And then we'll combine like terms. And that is it. After that, I'll have you look at it. This is supposed to be the medium to hard part. After this, it gets easier and easier. And then I'll give you an assessment. Oh, that was sweet. Alright, here we go. I'm still going to put this red line here so that they know we just did the middle piece. Let me have you attempt to do it. That way when we build it together the second time, you're like, okay, did I get it? So go ahead and do first, outer, inner, and last. Try it, see if those negatives don't mess you up. If they do, I'm going to put the right answer on the board. You get to see it. And that will be it. There are only 3 pieces of the puzzle today. This is one of the 3. If you feel good already, then congratulations. That's what the next puzzle card. Also, as you are multiplying or doing your work, also that good just so you have some math talk. You are multiplying binomials. Binomials just means it has 2 pieces in each parenthesis. Binomial. Bicycle. Bible. Give you a moment to try. Some of you tried on some of this. The part that I don't kind of like about this particular one is that they put that x out of place. Like they put the x5 minus x, which normally they'd put the x minus 5. You don't switch it around, but that part I don't like. All right. The box method. The box method is the same thing. You multiply the first guy, top row here, times the first guy, times the second guy. You get your bottom row, you multiply the bottom row guy, top, times the last guy. Here it comes. Someone say it out loud if you know it. If you say an answer, don't do the other. X squared times the 5, please say it out loud. I know what you're thinking. I know what you're thinking, right? If you squared 5, but this time it really is just the x squared times the 5. Somebody want to help them out there?
X squared.
So fortunately, in this case, when you're multiplying a number times a letter, and I'm going to put it up here as well so you can see both versions, they just stick together. So x squared times the 5. Somebody might say, shouldn't that be x squared 5? Like this. Do this, and not here. What's another teacher? Do this back way and see if it bothers them. I'm interested to see what math teacher is like. Hey, look. In my class, you do not write the coefficient behind the letter. Try it. Let's see what happens. I don't think they shouldn't go crazy, but if you do it enough times, I think they will. That's just wrong because some other teacher could be telling you to do something here that drives me crazy. Turns out with math, nothing does. I don't care. No, all right, here. So here we go. X squared 5. That looks weird. Yeah, do it. Do it! Okay, whatever. I don't know. They're gonna be like, and you're just waiting. You know, like, what? What, you gonna say something? Sure? Just keep doing it. Alright, so here we go. Next guy. Okay, I have to switch it because it's messing with me. I'm gonna switch it back. Alright. 5x squared, there it is. Second one, someone please say it. An x squared times a negative x to the first power. Yeah. We just lost some people right there. Yeah. If this were a game where I was betting who's going to come off, who's going to miss one, right here, boom, the negative sign, that's the one. No. The 3, like, what the heck, where are you getting the 3 from? I'm not sure what they would put. They'd probably just put x squared, I guess. Alright, in any case here, the second rainbow goes here. Negative x cubed, or it's the third power. 2 plus 1, no big deal. Bottom row, someone please help me out. Oh, negative 1, thank you so much. Negative 1 times 5, someone say it please. Negative 5, you're out the pool. And again, notice how my 5 kind of looks like an S. I just wanted to remind you, if you blanked out the day I said it before, I feel like I may have said it, that you have to make a decision about which one of these is the 5, which one is the S, the world of math. To make an S a true S, we put these little things on them. So if you don't see one of those things on them by true mathematician, which you are now, and technically this guy is the 5. Yeah, he's a 5. S would have to have a little tick mark on it. Same thing with the letter Alright, this plus sign and the T. Which one is plus sign? Which one is T? Front or back? Yeah. The rule is in the world of math, we make a T with a little curved guy on there. That makes it a T. There's another guy, 2 and a Z. 2 and a Z. What do we do to make it a Z? Again? Yeah. We throw the little guy in there like that. 0 and an O. Well, how do we do? Yeah, that would be good. Except we don't use O's. Sorry about that. For the most part, you will not see O used as a variable. So you don't have to do anything. And so if I had to make an O and a 0, I don't have a thing. Like if someone's actually made an O, I don't know. I mean, yeah, I think that guy, he would make it a 0 or he'd make it an O. I don't know which one. Alright, just so you will have heard it once. Someone else, negative 1 times a negative x. Someone say it, please. Yeah, dang it. Perfect. Except we got these little undos. Wouldn't life be great if we had that little button in real life? We just undo something we did. Alright, there we go. Tick, 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 where is it? Positive x. I'll put that plus sign. You don't need a plus sign there, but just put it. Alright, now, oh, up here, negative 1 times 5 is a negative 5. Negative 1 times that is a plus that. Some of you can see why some people just do this thing up here, because they can see that times that, that times that. They don't need the big box. For some people, this big box feels right. Alright, so I got this first guy, I got this second guy. Can someone tell me what to do to get this third guy? Yeah. If there's just one parenthesis and there's a plus sign in front of it, you just tear off the parenthesis and you have a plus x and a plus 1. If there was a minus sign in front of that parenthesis, you just change the sign to the opposite of everybody inside. I almost want to give you credit for applying that long time. Because chances are a sign's going to be off. So when I do grade it, if it's just a sign here or there, I'll be like, oh, okay, now you're fine. If some of your stuff's just crazy, then of course we'll have you go back and do it. On the assessment, there'll be 2 of these guys. The rules says essentially, if you get one super good, but you mess up a little bit on the other one, they'll believe you could do both of them. So if you do one super good, just shoot. Just know that, okay, I'm going to go through with it. But if my first one's super good or my second one's super good, then it will essentially say that the other one's okay. Last step, combine like term. Anybody who has an x3, x to the third power, we get together. Anybody to the second power, we get together. Anybody to the first power, we get together. It's long, it's the hardest one. It's the first thing on the test. Matter of fact, I'm probably going to recommend maybe that you do this one last. I do these stuff, I don't know. Here we go, let's find out. Where are you, x cubed? There's only one of you. I don't see anybody else. Anybody see another one? Alright, so I'm writing my answer where? I'm going to write it down here. I'm going to do negative x cubed. Should I write it in red? No, I'm going to keep it all in black. Sorry about that. Alright, here comes the x squareds. Okay, I see a 5x squared. Anybody else? I see a minus 6x squared. Anybody else? No. Here's the second part that's going to mess that up. You have to do 5 minus 6. It's possible somebody here does not do that. I'm giving you calculators. So I guess you can punch it in. And I know how much 5 minus 6 is. Just like it. And there's some people here like, I don't know how you got that. Should be 11. Should just be a regular one. It's all a mystery to them because whenever someone said the rules, they did some junk like this. If there's a minus in the middle, you can always just do click, click. You can kind of make a plus sign and a minus sign, and they're like, fine. Like, why would I do that? It doesn't matter why, you just do it. And then from there, now is a 5 plus a negative 6. Shouldn't that still be 11? Same 11 I'm going to put down? And then they go like, it's probably 11, but no, the sign. Look at the sign. Like, you mean negative 11? No. And then finally go like, I hate math. I don't know how to say it. I don't know how to say it. Just in case you're one of those people. And you don't have to let other people know. A long time ago, a math teacher should have done this. When you add numbers that are different signs, they should have put down the number. There's 6 minus signs. 1, 2, 3. 1, 2, 3. They should have put down 5 plus signs. 1, 2, 3, 4, 5. They should have done that. You scratch off the ones that have partners. You're gone, you're gone, you're gone, you're gone, you're gone. All that's left is a dash. One dash. How do you say you have one dash? Well, you put a dash to show that you have it, and then you write a number to show how many of them there were. There's a negative number. Too much work, the kid said. I'm not doing all that. I'll be putting 11. It's fine. Put 11. Fortunately, this class is not about this, which is why you're going to have calculators, and you do it. So what is all that about? This x squared will be a negative 1, which they won't write the 1, but I will this time. X squared. I'll write it. I'm also going to go put on the air for just a second and go from there. All right, here we go. Negative 1 x squared. The next guy in line are the regular x's. Here's a regular x. Oops, that. Double lines. Here's a regular x. Here's a regular x. Here's a regular x. 4 regular x's, or x to the first powers. Can I mess up somebody who hates math already? I gotta get rid of the 1. I got to. I can't keep it there. If you write 1x squared, I will take it. But on a standardized test, if you take an s back, which is coming up, they would never have a 1 in front of an x, because 1 times anything is just that thing itself. If you wrote in a pen, this is why you should write pen. I think I have a pencil. If somebody was out there writing pen, I need to give you a pencil. You can trade me for it. It's just going to be a minus x. If you kept the 1, you're not wrong. It's just they don't do it. Sorry. All right. All these other x's, where am I going to put them to add up their numbers? I'm going to put it over here. I'm going to erase this little thing here. Let's see. The first x was a regular x. The second guy in line had a 3. The second guy, a negative 8. And the next guy had a plus x. Let me also do this. Impressed that you would persevere through this problem. That's one of the things that kids want to do. They have persevered. Yeah, look at that. Number 1 under Common Core. What they want from students nowadays. They don't want you just to learn math anymore. They don't want you just to learn English anymore. They want to put you in a situation where some stuff doesn't make sense, but you're going to persevere to get to the end, because in the new workforce, they're not just going to tell you what to do. At least that's the idea. They want the new student to be able to get in a situation. All right, we need to figure out the problem on sector 7. You know, what is it? Like, that's what we want you to go in there. See if you can make sense of it. Once you do, persevere into solving it. Look, here are all the tools you have. Number 5, use whatever tools you need to figure out the problem. And then, where's that one about regularity and repeated reasoning? Look for and express regularity and repeated reasoning. In other words, if you see a pattern going on, kind of utilize that then to kind of show you, even if you don't understand why it's doing it. You may not understand why when the 2 x's get together it turns into x3, but if you see that again, do that. So that's technically what they're doing now. In any case, here it goes. I'm going to put a 1 in front of this x. I'm going to put a 1 in front of this x. Allow me to do all the positives first, and then have them fight the 8 after they're done. In other words, we have 1, we got 3 more, I got 4 of the positives. 1 more, I got 5 of those puppies. I got 5 of the positives. And they're still going to be fighting this negative 8x, which isn't going to be so good for them, because they're not going to win. So I'm going to say out loud what 5 minus 8 is. And negative 3. Now somebody who made it from 4 said, whoa. A second, are you telling me that whenever the small number minus the big number, it's like regular subtraction, and then you just keep the minus sign? Like you just do 8 take away 5, and that's a 3? And then because the negative sign was on the 8, you keep that like that? That's what it's been all this time? Yeah. Yeah. The person who doesn't get there, they just put 3. They're like, I don't know why they reversed it, but I'm going with the 3. Alright, let's see if we can get the last piece. Did we get everybody? There's a negative 5, a C5. There's a 4. There's a 1. My real question in my head is like, why would they make it so long? Like, is the point of this problem to see how well it can keep things organized? Because once you've done the positive negatives a few times, like, why have it so long? In any case, I'm just trying to help you get some points on this thing, so I won't ask any questions. There's a negative 5. where's his friend? The next guy in line was a positive 4, and then that positive 1. Yep. Again, allow me to put the positives together, combine them, and see what happens. The positive 4 and the positive 1 gives just a regular 5. And now I'm left with a negative 5 plus a positive 5. Anybody know the answer to that one? 0. A long time ago, I'm going to say it one last time. Oh, I'm going to put plus a 0. I'll put it, and then I'll erase it. Plus 0 means I really did get the answer. Blank could mean like, I didn't even see those extra numbers. So, I'll put it. I'm going to also show a question I used to ask when I used to teach junior high for my first 7 years teaching. This is year number 23. I would try to get them to ask a simple question with, I think I did with starburst, with positive and negative numbers. When you have different color starbursts, I put different numbers in each hand, like 3 starbursts here, like 4 starbursts here, and then be different colors. I say, who has more? Who, the red or the yellow? In some cases, they weren't that good mad, like, oh, obviously it's yellow, it has 4. And I say, how much more? Well, it has 1 more. 3 versus 4. And I'm like, well, that's the positive and negatives. And so eventually we'd do this. This isn't for everybody, just for somebody who like you never heard it this way. There are 4. Let's do 4 of the negatives and sure 3 of the positives. So the question would be: don't look at the sign. The sign is the reds. Those are the red starburst here. The green starburst. But who has more? Well, the reds. Clearly, they have more. And then how much more? They only have 1. Okay, we're bad all the time. I'll leave it alone. But the idea is, seeing that the answer was a negative 1 helps. I'm moving on. Let's go to the last thing we're looking at. If you look at what's inside this box, the question you're going to ask yourself, I'm about to leave it. But inside the box, are there any pieces inside the box that are like, oh, look at that? This guy right here? Let's see, where did he come from? He was this guy here. I'll just write up the guys who belong to his family. Here's one of his family members here. No, he's the square. Where the square is, that 5. 5 is from the family member. Where's the second family member? That -6. Anybody else was his family? No. So those were his family members there. Basically, what we did, we took the 5 and the -6. We said 5 minus 6. We said negative 1. And technically, I could put this negative 1 in front because it belongs to that family. How many x2s do we have? We have 5 of these x2s, and we took away 6 of these x2s. Oh, I'm left with negative 1 of these x2s. He's a standalone. He didn't have any family. Yeah. He grew up poor and alone. So funny. Alright, now. Don't worry, he's successful. Alright, any other questions about any of these numbers in the box? Don't say I'm about to walk away from it. Last piece, no, put the +0. If they have a +0, put it. Alright, okay. That's the hard part. This is page 58, page video, page 58. I'm trying to get to page 59. Circle 3 equivalent expressions. Basically, write this in 3 different ways that look different than what's up there, but it means the same thing. So here's the first way. I'll do it with just x's because that might help someone who could confuse them. I'm writing a brand new problem that looks the same right next door to it. So it doesn't have this whole x minus 2, but I'm just writing a brand new one. Can someone say another way to write x to the 2nd power? There's another way we can write it that means the same thing. Good job. X times x, you put a raised dot. I'm going to remove that raised dot because 2 letters right next door to each other means multiply. So let's see if I can get rid of the raised dot. For those who, yeah. For those who have no idea what that is, you don't need to know. I just like, all right, here it comes. Boom! One of the three, you just did it. But we did it without the big thing. In other words, anything raised to the second power just means that thing times itself. In this case, it's like a little baby x. Over here, they have this whole thing. So I'm going to give you an opportunity. I'm going to come and check mark. I'm going to put it in red to see what student will follow the pattern. This whole thing I wish I would have put in red so it could be just like my red thing. This next line, due to this problem, what I just did to this problem. Yeah, try write something down. Write anything down. I want to see what you would get. Things not working out. So that's why I try to offer to you. In the math class, what? I got a check mark just for trying, even from home? Yeah, just for trying. And then you get to see the real deal. If this whole thing were just the letter X, we'd write this whole thing twice. You must restart your computer to turn on. I don't want to use the user account control. All right, whatever. You write this whole thing twice. The end. Here's what I mean. I saw it on a couple of pages. Other pages saw some really creative stuff. And if we need creative people in the world, you're the ones. In math, not all the time. Let's go to. There's the red stuff twice. There's 5. Write it down if you don't have it. You can have it. It's free. How can this be? How can this be an equivalent thing to that? This thing raised to the second power means this thing times itself. The next thing we're going to do is we're going to FOIL it. That'll get us our second thing, our second equivalency, and then our equivalent expression. After we FOIL it, to get the third, we're going to see if we can find one number that we can add to 5. There are 2 extra things we can do. We'll do one of them. And then I'll say to the other people, oh, we could have done this, but we'll just do the easier of them. And then that's it. This is piece of puzzle number 2. There are 3 pieces of the puzzle. That first thing we did, that long thing, that's 1. This little baby guy is 2. And his friend after that is even more of a baby. So here we go. So this is, I'm going to put 1 here and I'm going to circle it. Like, what does he have 1? That's 1 of the 3 that I need. How can I get my 2? I'm going to rewrite this thing here. Keep it in red so it doesn't mess up some student. Like, how do you turn black? There it goes. Let's do that. What am I about to do right now? I'm about to FOIL it. That little thing we did on the other page. 5, you're not involved. You just get to watch. Here it comes. All right, let's do green and blue. Red and blue. 1, 2. 1, 2. Algebra, pause, this one now. All right, someone say what x times x is, please. Thank you, you're out of the pool. Someone else, what x times a negative 2 is, please. Say it again. Oh, yeah. The x and I see what you think about that 4. Negative 2 and the x. That second rainbow. And I do the rainbows to keep in order. Someone different. This negative 2 times an x, please. Thank you. You're out the pool. And then this last one, this negative 2 times this negative 2. It's a positive 4. Yeah, I know. Everybody's negative. How's it got positive? They just made up the most of a perk for the confused students, and I hate that as a teacher. I just feel so bad. I feel so bad. Those with good memories, though, it's easy. It's those with bad memories trying to figure out why it thinks that your life is terrible. Because the why is so not like, even when they say it, well, that's because you have, and you're like, all right. Guess what? By doing this here, bringing down that 5, that was it to begin with. We didn't do anything with the 5, we just did stuff there. Booyah! 2. You did 2 already. And the second one, like, what? I just did that on the other page. So you give me another point for doing something I already know how to do? Yeah. Yeah, I like that too. I like getting money just for walking. Like every time I take a step, I wish you'd option to give me money. Because I want to walk anyway. Look at me walk. See me walk? I'm making money right now. Making money. $76,000 a year. I just see because of all the answers. Everybody passes. Except 2 of you, I have to give you the wrong answers. Everybody passed. They know something's wrong. 2 people didn't pass. Sorry, whoever you are. Oh no, the kids were absent. And they come like, oh, I want to learn, and just write wrong stuff on the board. And that's so easy. Now, plus it's recorded. I wouldn't do that. All right, here comes number three. Number three is this. You see these two little numbers here at the end? If we were to combine them, we have a third row. I'm going to combine those two little guys. I'm going to keep everybody else the same. Then to some people who are good in math, I'm going to say to you, we also could have combined the negative 2's. But we're not going to do it. I'm just going to say that to you. The people who are not good in math, you're going to be like, do we have to? I'm going to say no, and you'll be happy. So here it comes. Third row. Keep everybody except the 4 and the 5. As a matter of fact, let me combine them first. Someone say what 4 plus 5 is, please. Oh yeah, look at that. I'm not quite sure why they're having this as part of that's something to learn, like being able to write it in 3 different forms. I'm not quite sure what that, like why that's. You put some box that I should have put boxes so that it feels like that's a complete answer. That's a complete answer. That's a complete answer. You know?
Plus 5, minus 7.
Any of the answer keys that I've seen wouldn't have you do that, but it seems like it would be an something about that seems too easy. Like, you hear what he's saying? Can I just put the 4 and the 5? Gonna switch the order? Is what you're saying, yeah? In the right class, at the right time, you switch them, and I think you could argue your case and get points. For our purposes, I would do it. It feels weird, but it seems right too. Because the other thing we could have done here, we could have combined the negative 2 and negative 2 to make it, oh, and negative 4x in the middle, and kept the 4 and the 5. We could have done the negative 4x and the 9, and that would also be another answer. So for those who are good in math, these answers will do, oh, those not good in math, these are good answers. For those who are good in math, again, those not good in math, don't even listen to what I'm saying. You could combine the negative 2, negative 2 to make it x minus 4x plus 9. You don't need to. Or you could have left the 4 and the 5 with 4x. So take a look at this medium section. I wish I had another problem to give you. Say, all right, everybody try one of these. I'm going to check mark it. Look at the 3 boxes. See if there's anything in any of the 3 boxes. We're like, hey, wait, where'd you get that? Wait, you know, and I'll say it to you. Then we'll do the last thing, and then number 1, if you pull it apart properly, that's the only way you can get these other guys. If you don't do number 1 properly, then the others will be broken. All right, here goes. Last move. But yeah, this last part's important. This is it. Oh, no, again, it's going to be done before you get back. All right, yeah, here we go. Last piece. How do I want to say this piece? I'm going to try and use smaller pieces to say it. The way I said it last year was simply this. Imagine this is a table. These 2 top things are sitting on top of the table. To get 2 of the 3 answers, circle the 3 answers again. Those who have brothers and sisters, you guys have been pushing each other. Maybe you're jumping on top of the bed and push somebody off. Which is, hopefully no one gets hurt. My little sister got hurt once, got cut over the eye. I didn't mean it. It happens. She's 3 years younger than we were kids. So don't push off the bed. It seems like fun until someone gets hurt. But basically, that's what's going to happen with these 2 problems. Step 1, x plus 3 is going to push 5x minus 2 off the bed. He's going to fall to the back. So that's one of the answers. 5 plus 2, 5x minus 2 is going to climb back out of the bed. He's going to push x plus 3 off the bed. 3x plus x plus 3 is going to climb back on the bed, and they're going to foil. I have no thing for that, but we're going to foil it, and there's the third answer. So for those who are like, what is this talking about? Let's see if I can say it this way. Let's do numbers. Simple numbers so that you can see. Let's make it, we can make them the same signs. Let's make it a positive 3 times a negative 2. They're laying on the bed. bottom is nice and safe. Nothing happens to the negative 1. When you're multiplying fractions, the two top numbers, really, it can be done this way. Let's see. Then I'll deal with the big one. Let's see. 3 times the 2. 3 stays on the bed, pushes the 2 off the bed. And now he's right side of the bed. And I'll tell him what that means in math terms. Whenever you're multiplying a whole number times a fraction, the whole number, the guy off the bed, is technically being multiplied times the top. In other words, this second problem here is where it normally starts. It said, please get the answer to this. 3 over 1 times the negative 2. Oh, all you gotta do is multiply the negative 2 times the 3. It gets onto the top of the bed. So, if they gave you this problem and said, please write it 3 equivalent expressions. Here's one of them. The second guy just falls off the back. Okay. Let's do it again. This time, let's make the front guy fall off the front. And that'll be the second answer. For those who are like, I have no idea what he's saying. 2 climbs back up on the bed. Pushes the 3 off the front. The 1 stays on the bottom. In other words, positive 3 times the fraction negative 2 over 1. Why is it equaling this top guy? You just multiply the whole number times the top. And voila, there you go. Let me say some math to you for a second. For all of us, I just want you to get the right answer. Both of these are correct. The red times the green and the black. The green times the red and the black. They're both right. So here's what I want to say to math people. Technically, I should have put the 3 behind. Why should we put 3 behind? Because here it looks like a mixed number. Like 3 and 2 over 1. It doesn't look like a multiplication problem. It is a multiplication problem. In math, we don't want to confuse people, so normally we'd put the 3 and put it behind. To keep the whole pushing people off the bed thing even, I'm just going to leave it where it is. Because up here, when we push this guy off the front of the bed, he's going to be sitting right in front where the 3 is. When we push this 5 off the bed, or the negative 2 off the bed, he's going to be in the back, right where the 2 is, but he's in the right spot. So again, if you're non-math, don't worry about what I just said. But if you're math, technically, this 3, we want him behind, so it doesn't confuse us. Like, is that a mixed number? Like 3 and a half? Is it like that? No, this is a mixed number. This isn't a multiplication problem. But for our purposes, since we're multiplying, yeah. All right, math. Hopefully you get it. If you don't need it. Just do what I do. And then the last 2. The last one, we're going to multiply these 2 guys. So here, a third way to do it would be, anybody know what 3 times the negative 2 is? I get it. Yeah. Okay. So here are the 3 choices. I wish I could put a 1, but add numbers. 1, push off. 2, push off. 3, multiply. Do the FOIL thing. I'm about to do with the ugly numbers. I don't have a second one for you to do. So once I do this last one, we'll check for questions. And I'll offer to you, which is bad as math, because normally they need a chance to be, okay, do I know how to do it? Oh, sure. Click here, but you won't have that chance. The good news is we'll be able to fix it if they're broken after. All right, there we go. I'm going to write them in color, or let me color it, and then I'm going to have you try to do the first or second move on your own. I can do the last one all together just to see who gets what already, and I can come around and check mark it. So what is it that he wants us to do? They don't have to underline this in red. I'm doing it in red so that you can see the connection between that guy, and obviously the bottom guy is the same. So Thomas, what does he want us to do? He wants us to do this second row. Go from this row to this row, but using the big stuff instead of the individual pieces. If you know what I mean, try. Well, let's try that. Thomas, I kind of know what you're asking me to. Oh, I know what you're asking me to do. I think I know what you're asking me to do. Like, could you repeat that? All right. Alright. Alright, thumbers, depending on where you are, you can begin. But again, basically I'm asking you to do to this big thing what I just did to this little thing. So we'll go from here to here. If not, you can wait it out. Because once I do it, you'll be like, wow, that was it. Yeah, just wait it out. No, but actually write something. Write anything. Write anything. And that way, where's all the stuff? Right. But by the time I write it, you are going to get one of these to do. I need to do this. Because the way I'm explaining it, knocking people off the bed, what does that do with math? I'm trying to get you to visualize it if you put this green thing behind. That's it. So here comes the first answer. Or the first version of... I'll put that... I'm going to keep everybody else black so they can see that the only thing that moved was the green. Can someone tell me what you did for the first one? That way, the fact that you knew how to do it, you get to use it. Alright. So here's what I think he's saying. Take a look at it. If you don't have it, definitely write it in. If you have it exactly that, then don't do anything. But if you didn't write it in, that's it. This is a multiplication problem. A fraction times another problem. Right, someone else say what, someone different, what the next line should look like? No? Let me ask this. It could be someone who got it right or someone who got it wrong. Exclamation point. And I'll put them in parentheses on the top too. Some people didn't have this first line. Sure, I'll put them in parentheses. You can stay in there. Can someone say maybe, whether you got it right or not, how maybe I should have said it so that it would have been obvious, like, oh, he wants me to write this, or this, like... Is there a way I could have said it? Like, or is the way I said it the only way to say it? Like, thank you. I know. I don't answer at the big meetings either. Even if I think I know the answers, usually basically wait around for about 3 or 4 people in the adult meetings. The answer, and go like, that's what I would have said. Any questions about these two? These are the easy ones. The long one is I'm going to multiply. Not what does it mean, just like, how'd you do it? Off the bat, I wish this thing was motion. Oh, it takes both of them out of its... Okay. The last one, I'm going to multiply the top pieces, which I think is simple to do. From then, we'll let you stare at it a little bit. I'm going to say something to some math people, but the 3 boxes that we've done, those are going to be the important ones. So I'll back up and say, look at it, look at it, look at it. I'm going to say something. Yeah, I'm going to say something about one of the problems. Last one, here it comes. Sorry for that, but you made it. Okay, I can do it. The x plus 3, the 5x. This is the part that, again, in the last one I gave this last semester, this is the part that messes some people up. Anybody can write this at the end, write this at the beginning. But this FOIL thing, if they can't do it, x times those 2, the top guys. And then the 3 times the guys. We're distributing, we're handing out food. X times 5x, I'm going to say that out loud real fast. Thank you. Someone different. Let's say x times the negative 2, please. Thank you. Someone different, please say the 3 times the 5x. Thank you. One last person, please help me by saying the 3 times the negative 2. Now here's what I'm going to do. I'm not even going to combine the middle terms, which you're supposed to. I'm just going to put all of this long thing over the x minus 1 and I win. So here are the people who are confused. If you're confused right now, you're not that good at foiling. The bad news on the not good at foiling thing is you need to be able to foil on problem number 1, then you can do it twice. You need to be able to foil on problem 2, it's the last thing you do on it. And you need to be able to foil on problem 3, which is this guy here. Take a look at it, see if there's something you may. Extra problem, just for minds to watch, minds that choose not to watch it or focus on it. Okay. X squared minus 25. Some of you've seen this thing before, you don't have it right. Just watch this. This is called a difference of squares. Difference because there's a minus sign in the middle. The rule simply says this. There's a formula that says if I have a squared, write really fast, a minus blue b. If you raise the second power and you raise the second power, there's a formula that says if I have one thing squared minus the second thing squared, the answer is going to be red, red, blue, blue, plus minus. Red, red, whatever number was for red. Blue, blue, whatever was for the other B. Plus minus. It is a formula. It is a thing that you memorize. If you haven't memorized, this one on here looks like they made numbers so big, like really. So you can't just give them like a baby problem just to show that they have it memory. You gotta make it like super numbers. Let's fill out what you at least heard it. Again, brains who are like, oh, listen, I don't need this one. Okay, I'll still listen. Should be that. Others may actually try it. So in this problem, how do you actually do it? Step 1, how do you write the first thing as something squared? Well, how do I write x squared? Put x squared. The first side is really easy. Can someone say how to write 25 as something squared? Get 5 squared. How do I write my answer? Red, red, blue, blue, plus minus. I used to say it, A, B, B, plus minus. So in this case, let's see, someone might be able to help me. What am I going to write in the first parenthesis? Anyway, red X and a blue 5. What am I going to write in the second parenthesis? Red X, blue 5, and a minus. Red, red, blue, blue, plus minus. What does it mean? I don't know. Just kind of what I want to say to math students. The why, yeah, it matters eventually. But really, it's your memory. If I memorize the formula, and then I remember to put things in the form of the formula, eventually when it's time to put the answer, I know it's red, red, blue, blue, plus minus. However I learn to memorize, it makes me a super math student. Up to a point. Eventually you have to figure stuff out, but a lot of it is just memorized. So now let me show the big hard one, and then from there, a minute to let your brains clear, give out your assessment, and then thank you for coming. What if they did crazy stuff like, and you'll have calculators you can mess around with if you try. Let's try 64 x to the fourth power minus 144. Yeah, at this point, some people like, I have no idea what to do. Watch this for those who are mathematically inclined. Maybe you did okay in your old math class somewhere. Let's start with the easy part. Someone who knows their timetables, tell me how to write 144 as something squared. Yeah, 12. For those who have no idea that it would be 12, all that means is your 12 timetables weren't super. You don't remember them. Now I want you always to feel that being not good at math is never, I'm not smart. Sometimes, oh, you're so smart, that's why you're good at math. No, I just remember it. The second part is a little bit harder. Let's start with the 64. How do you write 64 something squared?
8.
And there's the 8. Remember the 8 timetable. Here's the hard part. How do I write x to the 4th power by something squared? Now this part could be a little tricky. Either A, because they've never heard it before. The people with the good memories, they've never heard it before. But after I put it up here, they will always remember it. And when they see that x squared and they're asked that question again, they'll be like, oh, you just... Here it comes. X to the 4th power, that's something squared, is just x squared raised to the 2nd power. When this guy is trapped inside the parenthesis, the two exponents get multiplied, not added, giving you this x squared. Right now, someone just memorized that. Right now, someone else just heard it and it's too much. I'm like, which is fine. I just want to make that point about math. The reason I know this is I heard it, somebody told me, and I wrote it. But watch what's even better. Now that they see all this, they know that they, and then write down the answer, they would write down red, red, blue, blue, plus, minus. Because they remember the formula. So I'm going to ask out loud. Someone help me to put this final answer down. Let's see. I know there's two big parentheses next door to each other. Someone tell me what I'm going to put in the first parenthesis. Red, red. What's coming behind it? I'm going to say something about that. All right. Someone say what we're going to put in the second parenthesis. What's coming after it? Well, normally it's A, B, B, plus, minus. By accident, you switch the minus and the plus. So, there is a problem that is of this caliber on there. But if a student missed it, they could still pass the assessment. In the past, I taught this guy to everybody. Math people, non-math people, good memories, bad memories. And here's what happened. By the time I finished trying to teach this thing to a non-memory person, it messed up this thing. This pushing off the bed thing. So they were so confused on this that they forgot, okay, when I get this, just click the last thing right behind it. And then put the first thing right in front of it. And then I don't know about this foiling. I'll get that part later. But they missed these two easy parts. And that's why, as I close now, this is what I really want you to have. Because this is on there, and there's some good memories in here, I just want you at least to mess around with it. You don't have to do that. Mess around with it. Hey, what does he want you to do right now? He wants you